Constructing Taylor series, group work 4, using the Maclaurin series expansion for 1 on 1 minus x to express the Maclaurin series of 1 on 3 plus 2x cubed. First step is to take out 1 on 3 to get the 1 in the denominator, and then we're using more manipulation, we get minus minus, which is a positive, which now looks similar to this expression. Let that value equal t, and we get 1 on 3 outside of 1 on 1 minus t, which is exactly the same as this in a similar form. Now, using the standard Maclaurin series of 1 on the sum of n equals 0 to infinity of 1 on 3 t to the n, from here we can substitute t in, and we can re-express and simplify it into this expression. And then now we put n inside the brackets, 1 on 3, the sum of n equals 0 to infinity of minus 1 to the n, 2 to the n, extra 3n on n on 3n, putting the 1 on 3 inside as n plus 1, we get the Maclaurin series for this expression from the simplified version of that. To find where the series is valid, we simply let t equal 0, since it was a geometric series. Sub in t, absolute value of x cubed is less than 3 on 2, express that in a simple form, and it is valid for minus 1.14, it's less than x, which is less than 1.14. Now part B. Using part A, you've got to find the Maclaurin series of 6x squared on 3 plus 2x cubed all squared. The first step is to recognise it's the derivative from part A. So, written like there, we bring the minus sign across, and we sub it into the Maclaurin series from part 1. Now, because the derivative can go through the summation sign, we can re-express it like this, and because the n is constant, we can separate the derivative out, and the minus sign comes here using this step here. Now we evaluate the derivative and simplify using this step here. 3 cancels the Maclaurin series for 6x squared. 3 plus 2x cubed all squared is this.
Alright, for part C, we're using part A to find the Maclaurin series expansion for 1 on 3 plus 2t cubed, limits x to 0, and use the fourth Maclaurin polynomial to approximate the same integral with limits quarter and 0. Alright, so our result from A is this, and we replace the x's with t's, and then we've taken the integral of both sides, taken our constants and sum out the front in this step, and here we've just evaluated the t integral and then subbed in our limits x. We end up with this equation for our Maclaurin series. Now we use the fourth Maclaurin polynomial, and we do n equals 0 and n equals 1 to get these two, and we don't go past n equals 2 because it's not to the order of 4 anymore. So now we've just subbed in x equals quarter into here, and we've equated and ended up with 0.0831.